So in this video, I'm going to show you an analysis I did of the mid-air collision between the Blackhawk and the CRJ in some 3D software. And I wanted to see with my own eyes and get some more precise idea of how the helicopter route, how close did it come to the glide slope of runway 33. Before I do, I wanted to thank everybody who subscribed to this channel. So thank you very much, and also for your insights and your comments, which have been very valuable and educational. There were some really interesting comments coming back, this is a horrible video, and this is just somebody waffling, and then some people outright blame the CRJ pilots. I don't know how in your right mind you can blame the CRJ pilots or the crew for this accident, but that's what some people believe. Now, aside from those kinds of comments, really thank you from the bottom of my heart. So let me get to just what this analysis is about. The NTSB's last press briefing was held by the chair herself. Why? What happened to the, other guy who held the first press briefing? Do you remember the guy who had the little award ceremony first? He thanked everybody and, was catching some shine there. And I thought it was very distasteful after, so many people died to thank everybody first and so forth. It was not a good time to have his awards, to hand out medals. But anyway, what happened to him, and why did she decide that she has to handle the press briefing now after they recovered the voice recorders? Could it be that she's already received pressure from the FAA and the military about not releasing certain information and massaging things a little bit in the press? So let's take a look at my little analysis here. So here I have a chart around the DCA airport. This is the Ronald Reagan Washington National Airport in Washington. And it shows helicopter route 1 right over here. And then when it crosses this line over here, it's helicopter route 4. And this is what the helicopter was supposed to take. And the accident occurred right around here. And this is obviously the airport. You can also see the altitudes on this chart. This is the ceiling of Route 1. And here we have ceilings of 700, ceiling of 1300, and so forth. And this is runway 33. The accident occurred here on its approach. And this is runway 01. So the CRJ was coming from here. It was setting up for runway to land there, but traffic control asked them to switch to runway 33. They accepted that request, and they made a turn, a slow, S turn to the right and back onto the final of runway 33. Now, this chart has a scale here at the bottom, which is very useful. So I can set it in my software and get the exact dimensions, and I can now measure distances on it. And I could also go and map on top of this a satellite image of this, so that I have the exact thing precisely and correctly. And what I then did is I added a three-dimensional route. And I'm going to show this to you here, that this route is in fact in 3 dimensions. It's this thing over here. We can show it like that. And it has different heights. So if I look at it from the side, it looks something like this. Okay. And we can look at this flight path like so. Starting at 1300 feet, and it goes to the ground, but here it is 200 feet. And the width of this thing turns out to be 500 feet. This is the width of the line on the map, is 500 feet. So this is the width I also picked for this three-dimensional representation of the flight of Route 1. And then what I did is I added a glide slope. Okay, so now we have this situation, and we can look at, let me take this away, we can look at this like so. And you can see here the glide slope of the helicopter, of this runway. It starts here at the threshold of the runway at 3.1 degrees, and it goes on like that. So it is exactly lined up with the runway. Is the glide slope. Okay, so let's take a look at it from the side. We'll color it in. And now what you see is the glide slope from the side. The blue here represents the riverbank. So the riverbank starts over here. That is the west bank of the river. This is the east bank of the river. And over here is the cross section, is how the helicopter route intersects this area underneath the glide slope. Now this distance over here is 42 feet with an angle of 33.1 degrees. If you take this down to 3 degrees, it's much less. Remember, some airplanes are going to come in low, some airplanes are going to come in high. Airplanes have heights, helicopters have heights, things have these inaccuracies. And then also, what prevents a helicopter from veering outside of this? Nothing. So as you can see, I think that these helicopter routes are far too close to the runway. I'd like to point out that when you're flying, when a helicopter is flying at a speed in excess of 60 knots, things happen very, very quickly. Another thing we can do is try to estimate the helicopter's speed by using the times that it passed over specific landmarks. And these times and landmarks were given by Jennifer Homendy in her press briefing, verbally. I wish that your NTSB would release them precisely, but they didn't. So let's work with what we have. And I'm going to start you at the Memorial Bridge. And so if we do that, knowing that we have a map that we can measure distance precisely with, we can go over the tidal basin here, through this channel, and down past Haynes Point over here, and then to where the collision occurred. And if I do this calculation, it does seem to me that the helicopter was traveling at or below 80 knots in the first part of the journey, and then increased speed significantly when it exited the channel. So here in the before it passes past Haynes Point, it probably started increasing speed. Now this is inaccurate and uncertain because obviously we don't know where the helicopter exactly was, and we're trying to measure based on position and time. So if the position changes for the time, then everything changes. But the helicopter could have, not knowing the data and just going by these verbal indications of where it was, the helicopter could have reached speeds well over 100 knots coming out of that channel. I have another observation regarding horizontal separation mentioned in the comments. Some people said there should be 1.5 mile horizontal separation and 500 feet vertical. Okay, so let's look at that and see what 1.5 miles look like. I'm going to pick a spot here in the center of the river on on this line with runway 33, and let's pick the spot right here, and we're going to draw a circle there that has a radius of 7,920 feet, which is exactly 1.5 miles. That's what that looks like. That's what that looks like. This runway here is 5,200 feet, right? And this circle is 1.5 mile radius. So that's what that looks like. Very difficult to keep horizontal separation of this distance, of such a distance, from this glide slope. I don't think this is the correct way to do it. Now, what does 500 feet look like? What does 500 feet look like? Let's do that. That's 500 feet. That would be a radius of 1,000 feet. That is half a mile. That is 1 mile. Okay, so let's discuss the analysis that you've now seen that I did here. Just a quick analysis. I mean, nothing super complicated. But if you look at that flight path, or the two flight paths intersecting on that final for runway 33, clearly you cannot have helicopters just flying through there with impunity. We need them to yield. They need to be asking for permission before they can proceed underneath landing airplanes like that, or underneath glide slopes. Forget it. It's too close to the runway. So I'm not suggesting that the helicopter route be taken away. I would suggest that there's horizontal separation and that gets treated like a runway incursion. So they have to hold short before they can pass through the approach leg of that particular runway and other runways of similar locations on airports elsewhere in the country. As far as horizontal separation, what kind of distances are we talking about? I think a 1.5 mile does not make sense near an airport like that. I mean, if the helicopter has to wait 1.5 miles away and then it has to continue and then cross over the runway, look, then all the other planes who are waiting to land have to wait for this helicopter to pass. Now you're just slowing things down. If it's too close, the air traffic controller will not have time to respond. So we need both. We need this to be efficient and fast, and have the air traffic controller give them the ability to respond if a helicopter, if there is an incursion into the zone which they should be waiting to enter. So it looks to me like 1,000 feet, 1,200 feet, 1,500 feet, around there seems to be reasonable in this situation. Remember, if a helicopter flies at 150 knots, then they pass 500 feet in 2 seconds. So 500 feet is not a lot. 500 feet is not enough. The other thing we need, besides a specific distance of horizontal separation and the pilots asking permission to cross that area, is they need a speed limit. So we need a speed limit. And what's a good speed limit? I don't think even 80 knots. 80 knots is, much faster than 80 miles an hour. But 100 knots is 150 miles an hour. So 80 knots is close to 90 miles an hour. I would say, in my opinion, 60 knots, 50, 60 knots. Give the air traffic controller time to turn them around. Give the pilots time to turn around. Give or to make a correction, right? If it's like a missile coming in there, nobody can really react fast enough. It's not the altimeter that was the problem. You can see that this flight path, Route 1, is too close to the glide slope for that runway. If an airplane just comes in a little low, the landing gear, hangs underneath that glide slope. Their tail hangs underneath that glide slope. They're banking, the wing hangs underneath that glide slope. Then you have margin of error in the altimeters. You have margin of error. That glide slope is just a line, but there's a whole airplane that has to fit in there. And then you have the helicopter. The helicopter also has a height. It measures altitude from the belly. And you lift up, to the top of the helicopter. There's another 20 feet. Add margin of error. Add that this helicopter is flying low to the ground. They have to avoid obstacles. There's winds. There's all kinds of things. We have to have a safety margin there. You cannot just put these airplanes so close to each other. Forget it. So I think that needs to be that would be what I would expect the NTSB to recommend here. So let's discuss a little bit about hypotheses of how people have connected the dots. Not only me, but also people in the comments have made some suggestions and connected some dots. And there's also conspiracy theories. Now let's talk about the conspiracy theories first. One of the conspiracy theories is that this Blackhawk was deliberately flown into the jet. So if you really think that, go buy a $20 RC car that can go pretty fast, 2 of them, and run them at angles and try to hit one another at maximum speed. Do it at night. Do it at night so you have close one eye. Look at it from the side, not from the top. Stuff like that. You're talking about something that's virtually impossible to do on purpose. It's not that easy to do. So I'm going to just set that aside as a stupid idea. Another one is that the crew was never on board, that this helicopter was flown remotely or autonomously, maybe controlled from the ground somewhere. Now, the military does have this technology, for sure. We've seen that. It's not just only possible, they do it. We know they do it. So it is a plausible scenario, but I don't believe this is what happened. I don't think we have to go there. I think that the human error is enough. We don't have to go to autonomous vehicles. We don't have to do that, or remote controlled. I don't think that. I think we're talking simple, a lot of mistakes and human error that played a role here. Now, I want to discuss connecting the dots, which some people pointed out. And this is that we have ADSB off. We have a helicopter that's flying too fast down a corridor. We have the NTSB not releasing cockpit audio. We have pilot and instructor disagreeing about altitude, but not discussing it or not correcting it multiple times in the helicopter. We have the helicopter flying too high. We have the instructor not really paying attention to traffic, but although he's verbally acknowledging traffic, but obviously not seeing traffic, or not acknowledging real traffic and not paying attention to traffic. So a hypothesis here that connects all these dots is the following: is that the NTSB has already been pressured by FAA or military generals, whoever, people in high-ranking positions in government, to not release all the information because there were some irregularities that happened in this Blackhawk helicopter. Things that some of it air traffic control is partially aware of, the FAA may be partially aware of, but they've turned the other way and looked the other way. Regulations were not always followed, but it was a habitual procedure that was unofficially acceptable to people. And we also realize, I have also been made aware of multiple other occasions where there were near collisions. I call it near collisions. A near miss is a collision. If you nearly miss something, then you hit it. Okay, so it's a near collision, not a near miss. But anyway, so near misses, near collisions, whatever it is. There have been other instances where these Blackhawks nearly caused accidents in the same situation. So if you take all these factors and you put them together, what do you get? You connect all the dots. So what if, as part of this check ride, they are going to do things that are a little reckless? They are going to race down the Potomac River, maybe to time themselves and see if they can break a record. right? And this is part of the game. It's part of the training center. This is one of the things that they do. When you get your check right, you have to prove how fast you can. You remember Top Gear had a reasonably priced car that they raced around the airport track there, the old airport track. And Rowan Atkinson won that. He beat everybody. He beat Tom Cruise and everybody. Rowan Atkinson, Mr. Bean, was the fastest. So maybe this training center has something like that. And they are racing on the way home after the check ride. They race down and they time one another. They time the rookie pilot who's getting the check right. When they do that, it's not, other traffic is not really a priority. Because they do this, they fly there all the time. They're focusing on not hitting things on the ground. They're flying close to the ground. And that's part of this thing. And so when the air traffic controller talks to them and says, hey, do you see that traffic, the automated response, this is the, I'm not even thinking about it, I'm just robotically responding to the air traffic controller. All you say is, traffic in sight, request visual separation. You don't even look where there's traffic is. Who cares? We're on a helicopter route. They are not flying there. That is a reckless attitude, but it may have been sort of an acceptable habit. So this also then could be a reason for turning off the ADSB besides the checklist. Remember I said the checklist could contain that, turn off ADSB transponder. But what if they know they're going to do a race, they're going to exceed, reckless speeds around a busy airport, and so that they don't scare other pilots or show up on ADSB displays in other cockpits, why not just turn off the transponder? So we don't show up on these cockpit navigation displays and we can do our thing. Nobody's going to bother us. Okay? So that's one thing. And I still have the question, did they request permission to turn off ADSB? Now, Jennifer Homendy said that they were not sure whether it was turned off or whether the equipment malfunctioned. Well, obviously, the likelihood that equipment malfunction is much, much smaller than that it was turned off. And Ted Cruz said specifically, he said explicitly it was turned off. So I think it's more likely to have been turned off than to have malfunctioned. Point is, they did not show. There may have been a good reason for it. And then, what about the altitude? So they're flying with night vision goggles. Some people have also said that the night vision goggles themselves display, I don't remember if it's QFE or QHN, the altitude above mean sea level or the altitude above ground level, AGL or AMSL. So QFE is AGL and QHN is AMSL. Now I wonder if perhaps when they were doing this if they were doing such a thing like a race down this route, if perhaps they use some procedure to set one's setting for what they read in their goggles to be showing lower than what it really is. In other words, when she says she's at 200, the helicopter is really at 300. But they adjusted her altitude display inside of her night vision goggles to show her flying at the lower altitude. So what she sees when she sees 200, it's 200. It's lower than what she's actually flying. She's flying 300. And what's their excuse? Well, their excuse is, well, we want you to fly the helicopter. This challenge works like this: is you fly as high as fast as possible. You stay below 200. Your altimeter is adjusted to show 200 when it's actually 300. And the instructor's night vision goggles are accurate. So when he reads back the altitude, he makes sure that she knows she's still safe. Now this is done for safety, right? It's done for safety because they are going to fly a very risky, high maneuver, fast, near ground level. I don't know. I mean, like I said, this is hypothesis. It's total speculation. But since the NTSB is not releasing cockpit voice recordings or precise positions of the helicopter or helicopter speeds, since we are getting spotty information here, I think we should be free to speculate and hypothesize. So that could explain a lot of things. This also might explain why this explains why the helicopter was flying high, why it was flying fast, why the air traffic controller did not have enough time to assess the situation properly. Overworked air traffic controller in an understaffed tower, handling all this traffic, and suddenly something comes up, which happens every day, every week, and he's not expecting a collision, but he's handling it like they always handle it. Do you see that? Do you see the plane? Yes, I see the plane. Visual expression, and they pass collision alerts and everything included. So I hope the NTSB will give us actual information and the actual data instead of verbally giving us a story here and spinning something for us and giving us half the story. But I would definitely like to hear the cockpit voice recorders of that Blackhawk, and I would definitely like to hear the actual speeds that the Blackhawk were, and I would like to know the exact positions that the Blackhawk were at various times. I would also like to know if the Blackhawk had ADSB in. I'd like to know if the TCAS was working, and if the TCAS was giving what the TCAS gave them inside the Blackhawk. Remember that these Blackhawk helicopters are essentially VIP taxis. Why are they supposed to fly so fast? I don't think they should be. I think they can maintain 60 knots or 50 knots down that river, especially when they're getting close to the airport. I think that we are closer to an answer, but we will probably never know the full truth of what actually happened here. I think there, as many people pointed out, there is going to be a cover-up. So, thanks for watching, and see you next time.